This is topic 8, superposition. And part 1 is to do with the principle of superposition. Principle of superposition. Copy down the definition and learn it. In simple terms, when two waves meet, they superpose or they superimpose on each other and form a new set of waves. The condition is both waves must be of the same type. Here are some examples of adding two pulses together. Let's look at these two pulses, which are identical, except they're moving in opposite directions. This one moving to the right, this one moving to the left. And where they overlap in the middle, they add on top of each other. +1, ++1, +2. So the displacement of the resulting pulse is +2 in the middle. Now look at these two. This one above the axis, so it's plus. This one's below the axis, is minus. And where they overlap in the middle, +1 plus -1 is 0, so no displacement in the middle. Now look at this triangle and this rectangle pulses. Where they overlap in the middle here, this triangular bit adds on top of this rectangular bit, and that's what it looks like this. Now look at this triangular pulse and that triangular pulse. One is positive, one is negative, and where they overlap in the middle, you can see that if we just look at this vertical line here, the displacement of this pulse here is 0. The displacement of this pulse here is -1. 0 plus -1 is -1 here. Along this dotted line here, this one has +1. This one has 0. +1 plus 0 is +1. And then you just join up these 2 points like that. Here is another example of adding two waves together. First of all, you can see that they are moving towards each other like this, and they start to overlap more and more, and eventually they pass each other completely like this and unaffected. And y1 and y2 simply stand for their vertical displacements. Here is an example of adding two waves. They have the same wavelength but different amplitudes. A has an amplitude of 4 squares. B has an amplitude of 2 squares. And if you add up their displacements vertical line by vertical line, you end up with these crosses. And if you join up these crosses like this sort of thing, like that, then you get the resultant wave. Here is an example of adding two sound waves, X and Y. They both have same wavelength, you can see that, but different amplitudes. This one is 1A, this one is 3A's. Another thing is they are out of phase, half a cycle out of phase, or 180 degrees out of phase. So the crest of one meets up with the trough of the other. So 1A plus -3A, and the answer is on the next slide. Using simple arithmetic, you find that the resultant displacement is -2A.